I'm ready.
All right, go for it.
Okay. Hello everyone. Welcome to the class. Today is 11th week and the first day of lecture. We are almost at the end of this semester, and I'd like to focus on more advanced technologies in road crash mitigation at this point of the course. As you remember, that we learned several techniques about how to deal with road crashes. We learned about several factors, and in this lecture today I'm going to discuss about some of the applications which are being applied in the industry and in the roadway network. So this lecture basically gives you a view of applied technologies, so that I feel you will get kind of encouraged about what you have learned to apply and what's going on in the real field. And this lecture specifically deals with application of ITS, which is Intelligent Transportation System, in the road network, and how it deals with the roadway safety. At the beginning of the presentation, I will give you a view of some of the applications and its usage and its effectiveness in mitigating roadway crashes in US and also all over the globe. And then we will move into some more details after like 10-15 slides. To give a definition of intelligent transportation system is basically applying knowledge from other disciplines, specifically mechanical engineering, electrical engineering, computer science, to have an improved productivity with a safe roadway transportation system. And this style or technique has provided proven set of strategies for addressing the challenges of assuring safety and reducing congestion while accommodating the growth in transit ridership and freight movement. Moving to the past literatures, McCaver, he in his research estimated that 26% of fatal and 30% of injury crashes could be prevented with total system-wide deployment in in-vehicle, infrastructure-based and cooperative ITS system in the US. Now, you see, the point is, the problem with ITS in deploying all over US or all over the globe is related with huge amount of money. So that's what we are considering as the only negative aspect of deploying this technique. So the previous literatures or studies which have been done on this field, sometimes you'll find this buzzword estimated, because we don't really know what will be the exact situation on the field, because we haven't deployed this system completely. As I said, it's related to money, and part of it is still on the research stage. Several author or researcher has divided ITS into several categories, but I'm going to focus on a couple of them in this lecture, and other if you mark at the amount of slides in this presentation, it's huge. So I'm definitely not going to cover all these things in this class today. What I want to do, I want to talk about it, and I want to listen whatever you think about these things, but several of the slides has descriptive statements. I want you to read these things of your own, because I don't think those are difficult to understand. I think you'll do fine. Having said that, the first category comes into three branches. If you have the technology in your vehicle, if the technology is deployed in the infrastructure, for example, in the road itself, beside the road, overhead gantries, and the cooperative, which involves communication between vehicles and all other aspects while you drive. The second category considers the application side. What is the effect of these instruments. For example, if a device, it might be built in the car or might be in the infrastructure itself, if it directly helps to avoid a crash, then we call it active. While the passive is it does not avoid the crash directly, but it helps to avoid any future crash, in anything that can trigger a crash. For example, in a congested roadway, think about it. Probably all of you has been suffering in a congested I-4. This situation, the research says that this congested environment, it does not provide severe crashes because the whole road is jammed with cars, so there will be no fatalities. But think about it, the rear end crashes, okay, that might get higher, and these things has been supported by the literatures. And the combined passive and active systems is relatively new concept, and it describes systems that monitor road environment, vehicle, and or driver for potential danger, and then applies passive safety features when a crash has been deemed to be unavoidable. So this flowchart basically shows the interrelation between all these things. So the category is basically on the viewpoint itself. So each category can be merged or built into other categories too. Let's start with the brake assist. It's kind of it's not new. It had been deployed probably a decade ago. What it does is, if a driver by any means cannot provide the brake at the right moment, then this technology will help the driver to help mitigate that wrong decision of the driver, and will apply the brake by itself. So this study by Bush in 2004, he found that if 100% of vehicles had this technology within them, then the passenger vehicle or car would reduce fatality by 1.3%, and motorcycle would be 1.32, and all these other figures. Now the question is, why 1.3? Why not more? See, the thing is, as you remember from the past lectures, is the crash itself is not due to one single thing. It's a random event, as I said before, due to coincidence of multiple factors. So if one factor fails, a crash might not happen. When a crash occurs, is the fault of a driver, maybe. It might be the fault of other drivers who are driving stupid, or it might be fault of the roadway itself. So when a crash happens, it's like every factors are merging into one single point, and then the crash is going on. All right. Let us move a bit faster. This slide shows the lane change collision warning. Many of the GPSs already have a built-in function which allows you to warn the driver when you are on wrong lane. Plus, it will have something extra that will not only warn you, but will take measures. The vehicle will itself take measure to bring you back in your lane. This one is probably known to everyone. The overhead message signs in the gantries in interstates telling you what's the condition of the roadway. The variable speed limit. I have some pictures in next few slides. I'm going to move it here. For example, this one. This one says there is no fixed speed limit in the roadway. Depending on the roadway condition, the speed limit is changing, and it's allowing driver to see to follow that speed limit on that specific weather condition.
It's a picture from Florida, right?
No. And the maximum minimum speed limit, it also varies. So we are now, see, the more speed, the less time, and you save time, and you save productivity. So we are not trying to fix the speed limit to one single point, rather we want to vary it depending on the weather and other conditions. This says that you have to drive 50 miles per hour for the next 1 mile, okay? And then another variable message sign after 1 mile will tell you what should be your speed limit, okay? this figure shows something about the low visibility warning system. In fact, at UCF right now we are working on a project something like this, which is dealing with the fog and smoke related crashes, because all of you probably remember that there were 80 people pile up in I-4 somewhere, so we're working on it, something related to it. And this figure also shows something to the travelers, some information. And this is the most recent deployment, which the vehicle itself will adapt the speed, and driver should, if a driver is not responding or he wants to drive beyond the speed limit, the vehicle will control itself. So these are the references I followed. Any questions at this point?
One question.
Yeah, sure.
How would you, I guess, criminal justice minded, how would the police officers be able to enforce the speed if it's constantly changing? They would have to be aware, mile by mile,
Right.
or constantly updated themselves. So is there like plans to keep them informed
In
as
fact,
well?
yeah, nice question. In fact, this thing, in the I-4, every half a mile has a loop beneath the pavement itself. So those loops are specifically, they are taking your speed, the volume of the road itself, and one other thing I forgot. So these information are real time, and they are going to the traffic management center.
Oh, okay.
Okay, so they are observing the real time speed of the vehicles. So depending on that, they can change what they can
Okay.
ever use. Sure.
Are these systems disableable in the event of an emergency? Like if you have a family member who has a snake bite or something,
Yeah.
you have to get them to the hospital. It really doesn't matter. And
Yeah.
at least I used to know. I don't know if this is actually still the case, but you